As part of last few topics, we study circuit breakers in two parts. So that ends the syllabus actually. So this is circuit breakers part 1. We'll go through now. So introduction. At the outset, a circuit breaker is just a switch, but it is a special switch. It's not just a simple switch, but it's a special switch. What it is, we will see. In terms of the operational and constructional requirement, however, circuit breakers are expected to perform much more rigorous duties compared to any other ordinary switch. As per the ANSA, American National Standards Institute definition, a circuit breaker is the only switching device capable of carrying, breaking, and making currents under normal as well as abnormal circuit conditions. Carrying in normal conditions, carrying in abnormal conditions, breaking in normal conditions, breaking in abnormal conditions, and making connecting in normal conditions and connecting and in abnormal conditions. These are all the operations a circuit breaker is supposed to do as compared to ordinary switch. Ordinary switch may not have these all capabilities, but circuit breaker is that device which has all these characteristics. The sudden interruption of a high energy inductive circuit leads to huge voltages across the switch contacts, which may damage the switch itself. Thus, any ordinary switch can't serve this purpose. So, a special switch is required, that is circuit breaker. Carrying, breaking, and making currents. What is carrying current? Carrying current rating is the RMS value of the current which the circuit breaker shall be able to carry continuously with the rise in temperature of its different parts not exceeding specified values. So this is what is carrying current rating. Carrying current means it is normal operating current. That's what it is. So in that conditions, the circuit breaker is not expected to generate abnormal heat or abnormal temperature rise is not expected in any part of the circuit breaker. That's what it is. And then breaking current rating refers to the maximum RMS current which the circuit breaker can interrupt. Can interrupt means in sometimes when circuit breaker is to interrupt the circuit. In that condition, what is the current, maximum RMS current that a circuit breaker can interrupt without any problem. And making current rating refers to the current which the breaker can handle during closing, even if line has short circuit fault. Even in that condition also it should be able to make it. Make it means connect it. So it is expressed as the peak value attained at first cycle when the circuit breaker is closed. That is why it is always higher than the breaking current, because it is the peak value attained at the first cycle while making. So that's why during transient itself. So that's why this is always greater than the breaking current. Now types of switches. So there are several switches you must have noticed at home. So this is a home switch and this is a plug key switch. You might have seen in laboratories, of course. And then this is a fuse. And this is MCB at home. Again, you might have noticed this is cutout. And in old homes, maybe still this kind of fuses are there. This is a relay. And this is a contactor, load interrupter, and this is a line isolator which isolates these by disconnecting these rods. So these are two lines like this, and then this central one may disconnect by rotating or something like that. So this is line isolator, and this is circuit breaker. So these are all the switches, but this is alone the circuit breaker. A typical circuit breaker is shown. Among the circuit breaker, again we have several types of circuit breakers that we will see soon. So these are all the various switches. But all switches are not capable like circuit breaker, which as per the definition you have seen just now, making, breaking and carrying. So now the switches are available at all voltage levels ranging from low as few volts to as high as 765 kV and beyond. This is equal to the highest rating is equal to any highest line voltage. Now 1200 kV line has come up in India, so there must be a circuit breaker associated with that, obviously. So this is how the switches are available at all voltage ratings. Basic operation remains the same, make opening, closing of an electrical circuit. It is, however, the voltage level which decides the construction of a particular switch. So its voltage level determines its construction. Of course, current also has a role. So in deciding the construction. So now all electrical systems contain inductances. All systems will contain inductances. Electrical systems will contain inductances, and irrespective of the current or voltage level, a sudden change of current is always opposed, due to which the change in state of circuit is never instantaneous and involves an electric discharge across the switch contacts. The severity of this discharge depends on the energy level of the system. That's what I said, not only voltage but also current. Therefore, the power level or energy level decides actually. And the storage elements such as inductances, capacitances involved in the system also will influence. Basically, inductance, when interruption of current is there, inductance, sudden interruption of current is not allowed by an inductance. Therefore, energy gets redistributed. There will be associated transient. Therefore, never instantaneous. The circuit change is not in an instantaneous phenomenon and involves an electrical discharge across the switch contacts. So the severity of the discharge depends on the energy level of the system. Now, relative performance of various switches. Relative performance of various switches. Here you can see a circuit breaker, a load interrupter, line isolator, contactor, power fuse. These basic types of switches are compared here. What is a circuit breaker? Circuit is here making, carrying, breaking under normal conditions. Then making, carrying, breaking under short circuit conditions are considered here for comparison. Circuit breaker, so it should make, break, carry in all conditions. Therefore, in all 6 cases, it is yes, it is capable of doing that one. Relative performance. But a load interrupter, what is load interrupter? Load interrupter can make, carry and break under normal conditions. But it cannot connect under short circuit conditions. It can carry short circuit currents, but it cannot break also under short circuit conditions. This is what is known as load interrupter. Okay, so it can work under normal conditions properly, and it can carry the abnormal current, but cannot make or break abnormal currents. That's what it is. The load interrupter can do. Then line isolator. So in the line isolator cannot make under even normal conditions also, and then it can carry the currents under normal conditions. Again, it cannot break under normal conditions. Similarly, it cannot make under short circuit conditions as well as breaking conditions. Only it can carry the currents. That is what the line isolator will do. Then contactor. Contactor can make, carry and break under normal conditions, make and carry under abnormal conditions, but it cannot break under short circuit conditions. So this is what is known as contactor. And then power fuse. You know the power fuse what it does. It can carry normal conditions, but it cannot carry under abnormal conditions or short circuit conditions. It can break under short circuit conditions. It can carry normal conditions, break under short circuit conditions. That is what a power fuse can do. So this is the comparison of relative performance of various switches. Now classification of circuit breakers. Now circuit breaker is the important switch. That's what we will study in this actually. So there are several types of circuit breakers. The classification is also not unique. There are several ways of classifying the circuit breakers here. So on the basis of voltage level, see, of course, before going into this classification, I should mention that there is no hard and fast definition that what is high voltage, what is medium voltage, what is low voltage. So here it is for circuit breakers, the classification is given here on voltage level. So low voltage is typically 6 to 12 kilovolts, medium voltage typically 12 to 72.5 kilovolts. High voltage circuit breaker is 72.5 to 123 kilovolts. For extra high voltage circuit breaker, 123 kilovolts to 765 kilovolts. And for beyond 765 kilovolts, it is ultra high voltage circuit breaker. So this is on the basis of voltage level. Next, on the basis of insulation. So indoor installation on the basis of installation, indoor circuit breaker, outdoor circuit breaker. So this where the circuit breaker is installed on that basis. And then other way, on the basis of tank design. Tank design is also an important consideration in circuit breakers. Therefore, there are two types here: live tank circuit breaker, dead tank circuit breaker. So there are two types of circuit breakers here. The next one is on the basis of arc quenching medium. So circuit breaker, actually there is a requirement for quenching the arc which appears inside the circuit breaker when we break the circuit. So, but that quenching medium, arc quenching mediums are different for different circuit breakers. So on that basis also circuit breakers can be classified. That is air brake circuit breaker, air blast circuit breaker, bulk oil circuit breaker, minimum oil circuit breaker, SF6 circuit breaker, and vacuum circuit breaker. So these are the several circuit breakers. Images are shown here. On the basis of voltage level, you can see this is 33 kV circuit breaker, vacuum circuit breaker. This is 138 kilovolt oil circuit breaker, 250 kV SF6 circuit breaker, 500 kV air blast circuit breaker. And 12 kV indoor circuit breakers are shown here, and then 300 kV outdoor circuit breakers are shown here. Similarly, tank wise, live tank and dead tank are shown here. This is dead tank type, this is live tank type. So obviously, live tank means it will be at high potential tank. Therefore, there should be isolation from the ground. It should be at a particular height. And dead tank can be on the floor, close to the floor. So this is how based on the tank type you can classify. And then air blast circuit breaker, so this is arc quenching medium basis classification. Air blast circuit breaker, this is vacuum, is the insulation, and arc quenching medium here. Oil is the arc quenching medium. Oil circuit breaker, SF6 gas is usually here, SF6 circuit breaker. So these are the various circuit breakers. And then what typical construction of a circuit breaker consists of? There are actually four main parts of a circuit breaker. Conducting parts or contacts known as fixed or moving, and then insulating part. Conducting part means the rods which connect, or the conductors which connects those contacts actually. So those are conducting parts. Insulating part, those have to be supported through some insulation. Even the body may be sometime insulation. Therefore, insulating parts are required. And then arc quenching part is is actually the arc quenching medium we have seen just now, air blast, etc., SF6 or oil, etc. So this, but arc quenching parts associated with this one, that mechanism is that arc quenching part, and then operating mechanism and auxiliary devices. These are additional to these things. So these are all four main parts of a circuit breaker we will see. Now conducting parts usually comprise one fixed contact and one moving contact. The fixed contact will be fixed, and the moving contact will make or break by movement from by touching the fixed contact. It will make the contact, and by going away from the moved fixed contact, then the moving contact will break the circuit. So this is how the conducting parts will be. During opening of the circuit breakers, the contacts should separate at an appropriate speed and distance. See, it should be fast enough to quench the arc. So the distance also should be sufficient to quench the arc. So therefore, the contact should separate at an appropriate speed and distance. That is very, very important. And the contact should be able to withstand the voltage appearing across them while opening. So the whatever voltage appears, that should be that they should withstand. So, and then during closing of the circuit breaker, what should happen? The contacts should close under a high contact pressure, because even a small contact resistance will cause huge heat loss there, I square R loss, and then that will cause heating up and then ultimately damaging the circuit breaker itself. Therefore, the contacts should provide a low contact resistance to minimize the ohmic loss. That is very, very important. High contact pressure and low ohmic loss. That is what is required for closing the circuit breaker. The contact should be rugged and have a good mechanical strength to tolerate the stress due to the forces acting upon them. So this is also very, very important. Very good mechanical strength is expected for these contacts or conducting parts. Next are insulating parts. Usually comprise the outer case and internal insulation media inside the circuit breaker. The internal insulation media as well as the outer case of the circuit breaker may be the consisting of insulating parts. The insulating parts serve the following main functions actually. To hold the contacts rigidly in place. So we have to keep the contacts in some physical place, so that this is to hold the contacts rigidly in place, and to electrically insulate the contacts from the ground. So this is also another function, and then to electrically insulate the contacts from each other when it is open. When circuit breaker is open, means it should not automatically flashover should appear, and then so there should be sufficient insulation for that under opening condition also. So these are the three main functions of insulating parts. The insulating medium should have a low dielectric loss at the rated frequency. So yeah, this is ideally required for any insulating medium. The insulating medium should be resistant to weather conditions, moisture, etc., and perform reliably, keeping in view the arc byproducts, high temperature, etc. So this is how these special conditions here. There is arcing every time whenever you open. There will be an arc. So therefore, some arc byproducts will be there. And then high temperatures are also expected inside. So therefore, the insulating medium should be resistant to these conditions under weather conditions, moisture, and then must perform using under normally reliably for a long time in view of this high temperature and then arc byproducts, etc. So then third one is arc quenching part. This part forms the heart of a circuit breaker and determines its breaking and making capabilities. So it serves the most essential function of extinguishing the electric arc, which is set up due to breaking of an inductive current. So the mechanism of extinguishing involves the flow of a high pressure fluid which blows away the charged particles and which are responsible for sustaining the arc. At the same time, the rate of rise of its dielectric strength should exceed the rate of rise of voltage across the open contacts of the breaker. So this is how we have to ensure the rate of rise of dielectric strength should exceed the rate of rise of voltage across the open contact. Otherwise, it will break again. So it will continue. The arc will continue. So this condition should be ensured while opening. So how then the flow of high pressure fluid, if you allow to flow a high pressure fluid across the arc, then that will blow away the charged particles and then thereby extinguishing the arc. So this is how the extinguishing mechanism will be there. And then operating mechanism and auxiliary devices. So operating mechanism takes care of movement of contacts. So how the contacts will move and all, that is being taken care by this operating mechanism, which must be carried out at a high speed and sufficient power. So that's very, very important. The operating mechanism should apply adequate force to open the contacts when the relay issues a trip command. So how circuit breaker operates? Circuit breaker operates based on the relay command, which will issue a opening command and closing command, something like that. So it should happen. The circuit breaker should be able to do it. So that operating mechanism should be capable of delivering adequate force to open the contacts when the relay issues a trip command, and should be able to close the contacts with a high contact pressure. Because if there is no adequate high contact pressure, then there will be certain contact resistance, then that may result in the temperature rise or failure of the breaker. So this is how the operating mechanism should work. The auxiliary devices include that relay control, indicating devices, etc. are auxiliary devices. So these are the main parts of or main constructional details of a circuit breaker. Now the physics of electric arc, let us see. So this is very important to understand the circuit breaker, how it works. We must know what is electric arc and where exactly electric arc will be in the discharge region. So let us study about briefly about physics of electric arc. The sudden interruption of an inductive circuit leads to very high voltages across the switch contacts, which is sufficient to cause an electric discharge across the open contacts of the switch by virtue of dielectric breakdown of the insulating medium. So this is what will happen when we suddenly interrupt the inductive circuit. So due to the very high voltage that appears across the contacts, so which is sufficient to cause an electrical discharge across the open contacts of the switch, because there will be dielectric breakdown due to the high voltage. That breakdown will cause these discharges. The discharge thus set up constitutes a current across the gap through ionization of the gaseous medium, and thus even after opening of the circuit breaker, the fault current is actually not interrupted for a finite time until the discharge is somehow ceased. So an electric arc is one form of the electric discharge, which is usually self-sustaining and characterized by low voltage drop and large current. That is what is electric. This is one of the forms of discharge. There are several forms of electric discharges. We will just see what is the complete characteristics of electrical discharge. Now, what is electric arc? Electric arc is one of them, and which is usually self-sustaining because it will sustain itself. So self-sustaining and characterized by low voltage drop. Voltage drop will be low across the terminals or contacts, and current will be large. So that's what is the nature of an electric arc. Now the physics of electric arc. The principles governing the conduction of electricity through a gap or metal vapor through a gas or metal vapor are based on the fact that such vapors always contain positive and negative carriers. So all discharges typically involve the very fundamental processes of production, movement and absorption of the charge carriers as the means of conveying the electric current between the electrodes. Three types of electric discharges are observed in the gases. One is non-self-sustaining discharges, self-sustaining discharges, and electric arc. So these three types of the discharges are observed in gases. Now physics of electric arc, in the regimes are given here. You can see how VI characteristics is given here. So for example, if you are increasing the voltage, then you can see this type of characteristics. The current slowly increases and then becomes constant, means saturation, and then again after certain voltage again it slowly increases, and then here suddenly, so this region is after saturation. The increasing region is called dark discharge. So this is background ionization region. Then here it is a dark discharge, and then at a sudden instant, suddenly the glow discharge starts, where the voltage drop is having these characteristics. You can see huge current is increasing, but voltage is decreasing. Voltage across the glow is decreasing, and then again the you can see the current increases suddenly to a high value at this particular voltage, and then here again this region is normal glow region and this is abnormal glow region. After abnormal glow, here's the arc discharge starts at a very high value of the current, and arc discharge is characterized again by very low voltage like this. So here until this region where the current is decreasing is non-thermal arc, and from this region it is called thermal arc. So this is the general VI characteristics, volt ampere characteristics of discharge or discharge regimes they are called. When a voltage is applied across two electrodes separated by some gaseous dielectric medium, the charge carriers experience a force proportional to the applied electric field. Due to this force, the positive ions move towards the cathode and the electrons move towards the anode. On striking the electrodes, the carriers give up their charge, thus producing electric current through the gaseous medium. This is known as discharge current. A continuous flow of this current is possible if the charge carriers striking the electrodes and getting absorbed are continuously replaced by new carriers. Then only continuous flow will happen. Otherwise, there will be no flow. After discharge, then there will be no current. So the continuous flow is possible only if there is a replacement. Then the replacement of charge carriers may happen through ionizing processes such as photoelectric and thermionic emissions in the region. So then the initially at low voltages, so in this region at low voltages, the magnitude of discharge current is extremely small, 10 to the power of minus 12, which is practically close to 0 and thus may go unnoticed. But however, if the voltage increases, it is observed that the current magnitude increases proportionately up to a certain value, 10 to the power of minus 9. Up to this region, it is proportionally, it increases. A little bit after that exponentially it will increase and then reach saturation. at which the rate of generation of new carriers is equal to the rate of absorption at the electrodes. So once this equilibrium is attained, a saturation is observed. So this is the saturation voltage. Even if you increase, there will be no further increase in the current. So once this equilibrium is attained, a saturation is observed where the current remains constant despite increase of the supply voltage to levels that are several times the level originally required to reach the saturation current limit. So this is actually several times. The value of the saturation current depends upon the intensity of ionization as well as on the volume and pressure of gas between the electrodes. So these are the determining factors for the saturating current. Then since the saturation current limit depends on the presence of charge carriers generated due to external ionizing agents, the regime of discharge until this point represents a non-self-sustaining discharge until this point, this regime. So as the applied voltage is further increased, even though there is no appreciable increase in the discharge current, the charge carriers experience high forces proportional to electric field so that their kinetic energy increases in this region. So the collision of these accelerated carriers with neutral atoms present in the gas results in the excitation of their electrons to higher energy state, or it may even directly result in emission of the electrons. This process is known as shock ionization. So beyond a certain voltage, this process of emission leads to shift of regime, and the electric discharge now assumes the form of a self-sustaining discharge. So here in this region. So in some cases, particularly in case of plane parallel electrodes, the transition from non-self-sustaining to self-sustaining discharge leads to an immediate complete puncture or flashover, which, provided that the voltage source is sufficiently high, will result in a continuously burning arc being established. So if the distance between the two electrodes is very high, so that the electric field falls rapidly with the distance, the transition to a self-sustaining discharge may result in only a partial flashover, in which the dielectric strength of gas is exceeded only near the electrodes, and as a result a luminous discharge known as corona appears. The transition of regime from non-self-sustaining to self-sustaining discharge is characterized by increase in current, while the voltage across the electrodes remains nearly constant. Here. During initial stages of self-sustaining discharge, the current density is in the order of few microamperes per square centimeter. The discharge has not yet become luminous, and consequently it is called dark discharge here during initial stages of self-sustaining discharge. As the current continues to increase, a luminous glow appears across the gas region, and a glow discharge takes place. So after this is before this, this is in the dark region before the self-sustaining discharge, and this is when the self-sustaining discharge has come into picture. So this is a glow discharge also called. So across the region, and in air, the glow at the cathode exhibits a very light bluish color, and the anode glow is salmon pink. That is the characteristic of glow. In the next region is the normal glow, where the cathode is not completely covered by cathode glow. The cathode current density at this time is constant. The region known as the abnormal glow is observed when the cathode is completely covered by the negative glow, as a result of an increase in the current. Here, this is the region of abnormal glow. Okay, as the current increases, the energy imparted to the positive ions is increased, which leads to a rise in the cathode temperature. So now the temperature rise begins, which in turn leads to a condition of thermionic emission. So that subsequently results an increase in the current accompanied by a rapid collapse of the discharge voltage like this. During this transitional period, the physical characteristic of the discharge changes from those of a glow discharge to those of a fully developed arc. So in this region, this is called arcing region. The IV characteristic discussed here is strictly valid for DC, of course, the voltage increased, etc. This is DC, valid for DC discharges in gas discharge tubes. However, similar phenomena happen during an AC discharge in air. Now, the discharge region usually encountered during the operation of high voltage circuit breaker is this region. Means in this entire characteristics, we are interested, our circuit breaker is in this region, arc discharge region. So, discharge region between H and K, this point H and point K. At point H, the hot cathode emits electrons by virtue of thermionic emission starts from here. So, the discharge undergoes glow to arc transition. This is glow region, this is arc region. So, glow to arc transition in this H2I, it undergoes a transition in this region. In arc regime, V discharge decreases as I discharge increases. This is V discharge decreases as I discharge. This is current, this is voltage, right? Voltage is decreasing as current is increasing. Arc changes from non-thermal to thermal arc with large current here. So from this time, this instance onwards, so the voltage of course increases a little bit, the current increases to huge value. So this is how the characteristic will be, the properties of electric arc. Now the properties of electric arc, it is a self-sustaining discharge. Among the characteristics, this is one of the self-sustaining discharges, which exhibits low voltage drop and sustains large currents. So the most commonly observed arc discharge occurs across air at atmospheric conditions. However, it is also observed at high and low pressures in vacuum environment and in a variety of gases and metal vapors. So the gases and vapors that serve as conductors for the arc originate partly from the electrodes and partly from the surrounding environment and reaction products. So from those, these gases and vapors will come. The gases and vapors that serve as conductors for the arc. So arc conducts through gases and metal vapors also. Those come from surrounding environment or electrodes and reaction products. An arc may be diverted by fluid flow or magnetic field, because arc consists of a current, it can be deflected by magnetic field also. And it can be, since it consists of physically some particles, then fluid flow can also push the arc away. So therefore it may be diverted by these two things. An arc behaves as a nonlinear resistance. Its value decreases as current of the arc increases. That's just how we have seen. An arc is usually in thermal equilibrium. Now there are two types of arcs actually, high pressure arc and low pressure arc. So the arcs that exist at or above atmospheric pressure, is a high pressure arc. They appear as a bright column and characterized by a small brightly burning core at the center. Okay, the core of the arc is always at a very high temperature. The core temperature under conditions of natural air cooling reaches temperatures of about 6000 K, and when subjected to forced cooling, temperatures in excess of 20,000 K are also observed. The higher temperature increase of forced cooling is the result of a reduction in the arc diameter, which produces an increase in the current density of the plasma. Therefore, the temperature rises. So, in case of forced cooling. Now, the second case is low pressure or vacuum arc. It's also called vacuum arc. So, the arcs that usually exist at pressure less than atmospheric pressure. So, for example, in vacuum circuit breaker. So, they share most of the characteristics with the high pressure arcs, but however, they are characterized by an average arc voltage of just about 40 volts, which is actually significantly lower than the arc voltages observed in the latter. So, the positive column of the vacuum arc is solely influenced by the electrode material. Because, in this case, vacuum arc means it's not air inside, but how the positive column means how the arc is sustained, because the arc is sustained by vapor, metal vapor. So, influenced by the electrode material, because the positive column is composed of metal vapors that have been boiled off from the electrodes. The vapor must have boiled from the metal electrodes. These arcs have a unique characteristics, which allows the arc to exist in either a diffuse mode or in a coalescent or constricted mode. So here it is, this is diffuse mode and this is constricted mode. So the diffuse mode is characterized by number of arc clusters with moving cathode spots. So here you can see the cathode spots are not fixed actually, but anode spots you can see here. So like this. So the diffuse mode is characterized by a number of arc clusters with moving cathode spots. In the constricted arc, the arc segments originate and terminate at fixed points. This is a fixed point, this is again a fixed point, this is a constricted arc. Generally, diffused arc occurs below 15 kiloampere currents. So this case arises below 15 kiloamperes. And above 15 kiloamperes, this type of constricted mode will appear. A current threshold occurs during transition between the two modes, which depends on electrode size as well as electrode material. Now, types of electric arc summary: low pressure, low current, high current, diffused arc, constricted arc, and high pressure constricted arc. Voltage distribution of an arc. So this is how anode, cathode, you consider this is a arc, and it is of interest to see how the voltage distribution will be, potential distribution will be from this electrode to this electrode. So this is the voltage distribution, this along the arc length given here, VA, VP, VCR. VA anode voltage drop around 5 to 10 volts, VP positive column voltage, this is called positive column voltage, and VA cathode voltage drop around 10 to 25 volts. The order of the magnitudes are given here. The voltage drop across the arc can be divided into three distinct regions as shown here. The voltage drop across the positive column is characterized by uniform longitudinal voltage gradient here in the positive column. The magnitude of this voltage drop depends primarily on the type of gas, the gas pressure as well, the magnitude of the arc current also, and the length of the column itself. So that's what on these parameters it will depend. Now, voltage distribution, the first extensive study of electric arc voltage relationships for moderate levels of current and voltage was made by Hertha Ayrton. So, on the basis of experimental results, he proposed an empirical equation. Empirical means experimental equation, based on experimental observation, which is known as the classical Ayrton equation. So, V arc equals to A plus By plus C plus dy by I arc. It's a non-linear relationship, you can see. V is inversely proportional to I, where V arc is equal to arc voltage, Y is arc length, I arc is equal to arc current, For copper electrodes separated by air, these are A equals to 19, B is equal to 11.4, C is equal to 21.4, and D is equal to 3. So this nonlinear equation is typically used for arc voltage estimation with position. Thank you.